So far in this chapter, in Lesson 5.1, you've learned how to expand and condense logarithms. You've also learned how to find the derivative of the natural logarithms. And so today in Section 5.2, we're going to learn how you find the integrals of the natural logarithmic function. And so there are two what you would classify log rules for integration. And the first one, if you notice, is just the integral of 1 over x dx. And so if we think back to when we first learned about integrals, what I would do here is I would go ahead and rewrite this as x to the negative 1 power. And if you remember, what would end up happening is my exponent, when I go ahead and add 1 to find the integral of it, would become x to the 0 power. And I would divide by 0, and I can't do that. And so that's why they have the natural log. And so the integral of 1 over x is just natural log of the absolute value of x plus c. Can somebody guess why there's an absolute value? Yeah, it can't be negative. Remember, natural logarithm only works with positive values. And so then in number 2, what they're doing here is they're generalizing actually what happens here with the natural log. And they're saying if you get 1 over u, okay, that's just going to be the natural log of the absolute value of u plus c. This is the one that I actually would focus on more so than not. Okay, and so the alternative form of the log rule, if you notice there in the bottom, is in blue. And that's the one I would try to remember. Okay, the easy way to write that, the integral of du over u equals. Okay, because that's basically what u prime is. So if you ever get an instance of where you get du divided by u, that integral is the natural log of u plus c. Okay. So let's go ahead and look at our next slide and see what we have. Oops, I skipped one. Okay, here we go. 2 over x. So just for kicks, what do you think the integral of this is going to be?
Natural log of
2x. Okay.
Which is 1 over
Let's try to do something first. And let me see if this will change your answer. If I write it like that, would that change the answer you just told me? What would the answer now be? Okay, let's bring down the 2. Okay. What is now the integral of 1 over x dx? Natural log of x. And then you have to have your plus c. Yeah. I said that. It said plus c. I know, but you said times 2, and when you say that times 2, oh, well, I didn't hear you say that. So that's the answer. That's your answer. Okay. Let's go ahead and look at the next one. And this one's a little different because it's not like 1 over x, or in that case it wasn't like 2 over x. So the easy way to do this is, you notice there's one variable. The easiest way to do this is to let u equal 4x minus 1. Okay? Now when I do that, I need to find du. And what is du? 4 dx. And so in this problem, I notice that in the top I have a 1, but I'm going to actually make this a 4. So outside, I make that a 1/4. Remember, I have to alter the problem a little bit. So really, this is now 1/4 the integral of du over u. Okay. What is the integral of du over u? ln of the absolute value of u plus c. Now, in this case, are you going to necessarily need to write down natural log of u? Probably not, because you can go ahead and jump right to the solution. So the natural log of 4x minus 1, and then plus c. And that will be your final answer. Okay, now the question is, and I know you're probably thinking, okay, when do we know how to use natural log and when do we know not to use natural log? The easiest way I can tell you is if the degree in the numerator is exactly 1 less than the degrees in the denominator, that's when you're going to look at natural log. So when the degree in the numerator is exactly 1 less than the degree in the denominator, that's when you're going to look to be natural log. So let's look here. If we follow that same thought, my degree up here, my power up here is a 2, right? The power below is a 3. So it's exactly 1 less than the top. Here there's nothing written, and then here you just have an x to the first. So once again, it's exactly 1 less. So that's going to be a candidate for a natural log. So we're going to let u equal,
What's the other option you'd be confusing it with? Natural log or real?
well, just to see if there would be another technique that you would use, be division.
So-
Yeah, it was. I know.
Yeah, 1 is x to 0, and 4 is x to 1.
So what's the derivative of x cubed plus x?
3x.
3x squared plus 1. And so in looking at that, you're going to notice that really what I end up having is I end up having du on the top, u on the bottom. So when I integrate that, it's really going to be natural log of u plus c, or in this case, natural log of x cubed plus x, and then plus c.
So you just answered the
Because if you use the numerator, it's going to get you nowhere, because the derivative of the numerator is going to be 6x.
But you didn't have a square on the du.
Squared on the
oh,
du.
two is right.
Oh, I just forgot, sorry, that should be a 2. Okay, sorry, I think we said it, I just forgot to write it. Okay. All right, let's go ahead and look at the next one. Okay, now we're going to get trig functions thrown at us. Okay, so obviously you already know what lesson we're in. So you think you're going to let u equal what? Tangent. So you could actually check.
The derivative of u is at secant squared.
Derivative of tangent is secant squared. Do you know?
I'm pretty sure she's right.
Okay, so in other words, if we let u equal tangent of x, du then will be secant squared x. So if I rewrite that, I end up really having du over u. So the integral of du over u is natural log of u plus c, which will just be natural log of tan x plus c. Okay, so far so good? Okay, so let's go ahead and look at the next one that I have. So I want you to go ahead and try and do this one. Yep. Yep.
I'll do it. Each two. Okay. Start with it. Evaluating
What'd you get you?
X squared plus
X squared plus
2x.
2x, mainly because if you compare the degrees in the numerator and denominator, you're going to notice that the numerator is 1 less than the denominator. Derivative is 2x plus 2. So really,
It's the same
what
as
that
the
is that's
about
2 times x plus 1 if you take that 2 out. Okay, so what do you need to multiply the top by? 2 and a bottom by, or and the outside by 1/2. So really what ends up happening is you end up getting 1/2 times the natural log of x squared plus 2x plus c. Okay?
You have to do it all the time.
Alrighty. That one looks real similar to the first, one of the first ones we looked at. Do you think you,
Let's just skip it.
no, but what do you notice u would be? 3x plus 2, what's du going to be? Du is going to be what? 3. So what are you going to have to do? Multiply by a 3, multiply by a 1/3, and we can, yeah. Okay. So that one's kind of one.
Holy crap.
We're not doing tomorrow.
I think we should expand the top to make it X. Maybe that way, make X 10,000. Let's not do this one. Get there. Have to do it X.
Oh, can you not do this one?
You can do this one. Okay, we've got a technique we've got to do first.
Okay, Lucy, they both have x squared plus 1 to the top. Can you get rid of it? Dang it. You have to take an x out, right?
Now, if you remember, once upon a time, we learned about long division.
What's long
And
division?
Oh,
you learned about long division with polynomials, and the question was, I was like, well, are you kidding me? When would we ever use this? Well, right now. Okay? And so we're actually going to do long division here. And so what I'm going to do, and the reason why I'm using long division here is because notice, these powers are the same. So a u substitution is not necessarily going to work. So what I do is I put these in descending order, and then I look, x squared times what will give me x squared? 1. So now remember, I take the 1 times each of the terms in the divisor. I take the 1 times each of the terms in the divisor, so I take 1 times x squared, and then I take 1 times 1. So I'm going to go ahead and place that 1 times 1 underneath the 1 because they're in fact like terms. Now remember with long division, what is the next step that you do? Subtract. Okay? You're actually going to switch the signs. Remember, this is where we switch because we're essentially subtracting. So x squared minus x squared, that's gone, there goes a 0. X minus 0 is going to give me x. 1 minus 1 is going to give me 0. So the only thing I have left is x. So now I look, does x squared go into x? No, it can't. So really, x is my remainder. So if you remember how we wrote the remainder, is we put x on the top over the divisor. Okay? So really, what ends up happening here is that I am now integrating, instead of the problem I gave you, I am now integrating this right here. So I'm integrating 1 plus x over x squared plus 1. So, what is the integral of 1? 1x. Because remember, you guys add 1 to the exponent. That was like x to the 0. Okay. Now, what's the integral of x over x squared plus 1? U is x squared plus 1. Du is 2x. So what do you need? Multiply it by a 2 and a 1/2 on the outside. So really it'll be 1/2. What will come next? Yep. Of C. Okay? Now, that was a good one to end on. And we'll pick up another one tomorrow. Okay? But you might have to divide if the degrees are the same. Okay,
If
so
it's
we'll
bigger on top.
then we'll talk about that as well. Here you go, page 338. Section 5-2, you have 1 through 25 odd, 29 through 36 all.